So today we are going to talk about 12.5 using recursive rules and sequences and functions. So right now, the past couple of notes, we've been writing an explicit rule, which is a rule that gives an as a function of the term's position n in the sequence. A recursive rule gives the beginning term or terms of a sequence and then a recursive equation that tells how an is related to one or more preceding terms. So for example here, if you look, they want us to write the first 6 terms of the sequence. They tell me a sub 0. I need to know a sub 0 because in my equation I have a of n minus 1. I can't find a sub 2 right now because I don't know what a sub 1 is. So the first thing I want to find is a sub 1. Well, a sub 1 is going to be equal to a of 1 minus 1 plus 4. That's equal to a sub 0 plus 4. A sub 0 here now, I'm replacing a sub 0 with what it is, which is 1. So this is 1 plus 4, which equals 5. A sub 2 is going to be a sub 2 minus 1 plus 4, which is a sub 1 plus 4. Well, now my a sub 1 is 5, so I'm going to plug 5 in, and I'll have 5 plus 4, which equals 9. Notice how I need to know the previous term for this example. So a sub 3 is equal to a sub 3 minus 1 plus 4. 3 minus 1 is 2, so I need to find a sub 2, which we just did, is 9. 9 plus 4 is 13. A sub 4 is equal to a sub 4 minus 1 plus 4. A sub 4 minus 1 is 3. A sub 3 is 13, so this is 13 plus 4, which is 17. And a sub 5 equals a sub 5 minus 1 plus 4, or a sub 4 plus 4, which is 17 plus 4, which is 21. So my first 6 terms would be 1, because now I'm starting at 0, 5, 9, 13, 17, 21. So there would be my first 6 terms. My next example starts with a sub 1, and they tell me a sub 1 is 1 here. So now I'm finding a sub 2. So I always start, if this is going to be where I started. So on the last problem I started at a sub 0, now I'm starting with a sub 1. So this is going to be 3 times a sub 2 minus 1, which is 3 times a sub 1, which is 3 times 1, which is just 3. A sub 3 is going to be 3 times a to the 3 minus 1, which is 3 a sub 2, which we just found out was 3, so then this is just 3 times 3. So all I'm doing here is multiplying 3 by the previous term. So a sub 4 then is going to be 3 times 4 minus 1, which would be a sub 3 here, so it's just going to be 9 times 3, which is 27. A sub 5 is just going to be 3 times 27, which is 81. And a sub 6 is going to be 3 times 81, which is 243. So here if I list the first 6, I start with a sub 1, which is 1. A sub 2 is 3. A sub 3 is 9, 27, 81, and 243. And there are my first 6 terms. So I have some, if you flip over your paper, I have some on the back for you to try on your own. So all I'm going to do, remember I'm hoping that you're pausing this video and trying these. I'm just going to list the first 6 terms, and if you have any questions, make sure you get them answered tomorrow in class. There's A, here's B, C, and D. So they ask for the first 5 terms here. All right, so there's actually recursive equations for arithmetic and geometric sequences, which makes this a lot easier than having to write it out. We can just plug it into an equation. So we need to remember when difference is constant, that's when I have my arithmetic. And when the ratio is constant, that's when I have my geometric. So for arithmetic, it's a of n equals a of n minus 1 plus d, where d is the common difference. And my geometric is a of n equals r times a of n minus 1, where r is the common ratio. So if I look over on the next page for some examples here, the first thing I'm going to want to figure out is what type of sequence do I have. So here if I look to go from 3 to 13 to 23 to 33 to 43, I'm adding 10 every time. So I know that it's arithmetic. And I'm going to use a of n equals a of n minus 1 plus my d. Okay, I know that my first term here is 3. And I know that my d value is 10. So when I write my rule, you want to make sure that you list a sub 1 or a sub 0 depending on where your term's starting here. If it's not listed, we're always just going to start with a sub 1. So a sub 1 is 3, and then my rule of a of n equals a of n minus 1 plus 10. So make sure you write your first term and then your equation. Next example, if I look here, to go from 16 to 40, 40 to 100, 100 to 250, I'm actually multiplying by 2.5 or 5 halves, however you want to write it. So that is going to be my R value. It's geometric, obviously, because I'm multiplying here. If I was adding or subtracting, that would give me my arithmetic. So here I'm using a sub n equals r times a of n minus 1. My r is 5 halves. So when I write my rule, I write my first term, which is 16, and then my rule, a sub n equals 5 halves times a sub n minus 1. I don't mind if you write 2.5 in here. All right, last example I'm going to go over with you. If I look here to go from 2 to 14, 14 to 98, I am multiplying by 7, so I have another geometric. My R value is 7, so when I write my rule, my first term is 2, a sub n equals 7 times a sub n minus 1. There are 3 problems at the bottom for you to write, for you to try, sorry. I'm just going to write the rule for you, hoping that you're stopping and trying these out. Practice is key. The only way you're going to get better at these is if you continue to practice them. Make sure if you try these and you don't get the answers that we have, that you ask questions tomorrow in class. So if we flip over, we have 2 more examples that I'm going to go through with you. So if I look here, to go from 1 to 1 to 2 to 3 to 5, what I'm doing here is I'm adding the number before it with the current one. So what I mean by that is 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, and the next term would be 8. So this is not geometric nor arithmetic, so these you're going to have to, there's no formula for it. So what I want to write out here, a sub 1 equals 1, a sub 2 equals 1, a sub 3 is equal to a sub 1 plus a sub 2, which equals 2. So when I write my rule, what I have is I have a sub n equals a sub 1. So here I was looking for my third term. A sub 1 was 2 behind n. So a sub n minus 2 plus the 1 directly behind it, a sub n minus 1. And that will give you the rule for this sequence. So if I look at the next example here, I notice I'm going to have to multiply by 1, and then multiply by 2, multiply by 3, multiply by 4. So I'm taking my n value and I'm multiplying it by the previous term. So when I write my rule, that's a sub n equals n times a of n minus 1. And that would be your rule for B. Last but not least, C here, if I look, a sub 1 is 1, a sub 2 is 2, a sub 3 is also 2. Well, to get that, I'm taking a sub 1 times a sub 2. So what I multiplied is I multiplied here, this was n minus 2, and then this was n minus 1. So my rule then is going to be a sub n equals a sub n minus 1 times a sub n minus 2. Or you could flip those around, it doesn't matter. I'm going to pause here and we'll finish the rest of these notes for day 2 of 12.5. Hope you enjoyed them and understood.